Okay, okay, friends. In this video, we will discuss about symmetry elements. What is symmetry elements? A symmetry element is an imaginary thing over which a symmetry operation is carried out to get equivalent orientation of a molecule. So, symmetry element is an imaginary element जिसके ऊपर we have to carry out symmetry operation or symmetry orientation. Then we will have equivalent orientation. So there are five kind of symmetry elements. First is identity, second is axis of proper rotation, and it is also known as symmetry axis. Yeah, axis of symmetry. Then third one is center of symmetry or inversion. Then fourth one is the plane of symmetry. Fifth one is axis of symmetry. Axis of improper rotation. Yeah, improper axis of rotation it is also known. Thus, over such elements, a symmetry operation is carried out for obtaining equivalent orientation. So, if we apply one of these five symmetry elements and after applying these elements, one of these elements, if we are getting equivalent orientation, then that is the symmetry elements. And these all are imaginary elements. So we can say that symmetry elements, the symmetry operation will give you symmetry. So symmetry is equal to symmetry elements plus symmetry operation. Now, one by one, we will study or we will discuss the symmetry elements. First one is identity. It is denoted or represented by E. E means identity, and its symbol is it. It's okay. It is taken from an heta that implies unity. It means E means unity or identical. This element leaves the molecule as it is, means no change is made on the molecule. If we apply or implement E symmetry element on a molecule, then it will not change anything in the molecule, or it will leave molecule as it is. So this element leaves the molecule as it is. Symmetry operation produce the identical structure is said to be identity. So after applying this identity element on the molecule, it will give us the identical structure, and that's why it is known as identity. For example, water molecule after rotation of 360-degree leaves the same structure. If we take example of H2O molecule, so you can see the H2O molecule, this is the it represents oxygen, this is H1 and HB. HA or HB means there are two H present in the molecule because its formula is H2O. So if we rotate this molecule with a 360-degree angle, so after rotation of 360-degree angle, this molecule will look like this. And these two structure, if we compare these two structure, both structure are exactly same structure. So E means 360-degree rotation. So we can say E means 360-degree rotation. So after applying 360-degree rotation, molecule is unchanged. That's why it is known as identity. Okay. Now we will discuss second element, that is the axis of proper rotation or symmetry. Axis or axis of symmetry. So if we define an axis of proper rotation or axis of symmetry, then it is an imaginary axis present in the molecule through which molecule rotates to take another position in 3D and gets equivalent orientation. So it is an imaginary axis. It is not physical. It doesn't exist. It is not existed physically. It is an imaginary axis. It is present in the molecule through which if we rotate the molecule with a certain angle, then it will give us equivalent orientation. Suppose we have A is a molecule and an axis is XY. Suppose this is the A and A dash. This is the complete molecule, and if we have XY and imaginary axis, that is axis of axis. Okay, if we rotate this molecule with 180-degree or a certain angle, then we will have orientation like this. A dash will be here, this side, left side, and A will be shifted towards right side. So these two are equivalent orientation. Why it is equivalent? Why these are equivalent? Because both are looking like same structures, but not exactly same. Why I'm saying it is not exactly same? Because here in this first structure, a dash is in right side, but in second structure, it is, or a dash is in left side. That's why these are not exactly same. These are not identical. These are not exactly same, but these are equivalent because these look like same. Again, if we rotate this molecule again with the same angle, certain angle, then A will be A will come towards left side, and A dash will be shifted towards right side. So now if we compare third structure and first structure, then we can see that these two structures are the exactly same structure. First and third are the exactly same. When if it are exactly same, then we will say these are identical structure. Okay, but first and second are equivalent orientation. So this axis which we have imagined that xy is an imaginary axis through which we are going to rotate the molecule A and A dash. So this axis gives us equivalent molecule or equivalent orientation of A dash molecule. So that's why we will say it is imaginary axis. So this is the condition. Any axis which can give or through which rotation gives equivalent orientation, that axis will be known as axis of symmetry. While if any axis through which rotation doesn't give equivalent orientation, that will not be that will not be axis of symmetry. Suppose I pass the axis through like this. Okay, so this axis will rotate the molecule and molecule will look like this. Okay, now if we compare this structure and this structure, these are not equivalent. This structure doesn't look like this structure. That's why this axis will not be in axis of symmetry. So with this imaginary axis, after two rotation with certain angle like a 180-degree molecule A dash gets equivalent orientation. That's why it is symmetry axis. So this is the condition for symmetry axis. That again I repeat that axis through which rotation gives same or equivalent orientation, then and then only that axis will be known as axis of symmetry. It is represented with Cn. Its symbol is Cn. And what is the n? N is n-fold axis, means n time rotation. After n time rotation, we have identical structure. Or in this example, first rotation gives equivalent orientation, but second rotation gives identical structures. That's why n value is 2, because after second rotation, we are having identical structure. So n is the order of axis. It is also known as order of axis, as well as the number of times the equivalent orientation arises through the rotation. So how can we find out the value of n? We can find out the value of n using this formula. N is equal to 2 pi upon angle of rotation, where 2 pi is equal to 360-degree rotation. So if we see this molecule, we have given 180-degree rotation. So with the formula 360 by 180, so it is giving you 2. So n value is 2. So with this way we can understand the improper axis of rotation. For example, if we take H2O molecule, it has C2 symmetry axis, and which is passed through oxygen atom. So this is oxygen, this is HA and HB. And if we put an imaginary axis like this, and if we rotate this molecule, H2O molecule, with 180-degree rotation or 180-degree angle, then it will give us this structure. So where HB comes in left side and HA comes in right side. And after this, again, if we rotate this molecule with that the same angle, 180-degree, then it will give us this kind of structure where HA will be in left side and HB will be right side. So if we compare the first structure and second structure, so if we compare these two structure, we can see that these look like same both, looks like same structure but not exactly same. Why I'm saying it is not exactly same? Because HA is in right side, the left side in this in this structure, but in this structure HA is in the right side. That's the these are not exactly same. But if we compare third structure with the first structure, then we can say these are identical structure. Why? Because in both the structure HA are in left side, so third structure is identical structure. So this is the first rotation. This is known as C21. C21 means first rotation with C2 axis. C2 axis means angle is 180 degree. And second rotation, it gives identical structure. So along the axis and with two rotations, C21 and C22, lower script shows degree of rotation. This 2. 2 means number of rotation, 2. And upper script shows time of rotation. How many times? So C21 means first time with C2 axis by 180 degree. The H2 molecule gets two equivalent orientation where after C2 rotation, it gets actual structure or identical structure. So, and यहाँ पे जो there are two levels A and B. These are just for understanding only. So with this example, we can understand the axis of symmetry. Therefore, in H2O, the C2 symmetry axis, which is passed through oxygen atom, and with two rotation with 180 degree angle, it gives identical structure. Okay, similarly we can find C3 axis in BF3 molecule. Suppose this is the BF3 molecule where we have labeled F1, F2 and F3 for just for understanding. So if we rotate this molecule with 120 degree angle, and the axis is passed through boron atom only. So after first rotation, C31 rotation, it gives first structures. It looks like this, and B both are same, not exactly same, but what are similar. Same, we cannot say exactly same, but same, equivalent orientation. Okay. So why equivalent? Because after 120 degree rotation, F1 has replaced F1 has replaced F2, F2 has replaced F3, and F3 has replaced F1. Again, say after second rotation with 120 degree angle through the same axis, it gives structure 2. And after third rotation with the same angle and same axis, it gives structure 3. So if we compare first and second structure, these are equivalent with original structure. But if we compare third structure with original structure, so those both are exactly the same structure because F1 is at its place in both the structures. That's why these are identical structures. So we can say that 120 degree angle rotation gives equivalent or identical structure in BF3 molecule. So if it is 120 degree angle, so we have to find out the N value. So N is equal to 360 by 120, it gives 3. So that's why N value is 3 and C3 axis is axis of symmetry in BF3 molecule. Okay, so thus to find out the symmetry axis, first find out the angle of rotation, then find out the total number of rotation at which molecule becomes identical or has symmetry element E. So this is the thing, or this is the way how can we find out the axis of symmetry. So first we have to find out the angle, and the angle of rotation, which angle of rotation we can take? We can take only that angle of rotation which gives equivalent orientation. So we cannot take any angle, we have to be selective. We have to take the angle of rotation which gives equivalent orientation only. Then and then only that angle of rotation will be known as symmetric angle, or can be considered for axis of symmetry. Similarly, in NH3 molecule, there is a C3 symmetry axis. This is passed through nitrogen atom. So if we see the structure, this is the NH3 structure. Its structure or geometry is pyramidal shape. So N is in the center and these are in the pyramid. So if we pass C3 and C3 or any axis through an atom only, and after 120 degree rotation, it gives equivalent orientation, and at the end after third rotation with the same 120-degree angle, it gives identical structure. So that's why we can say it has C3 symmetry axis. Similarly in tetracyanonickelate and tetrachloroplatinate, there are C4 symmetry axis is present, and that is passed through nickel and platinum atom only. So if we see this structure, tetracyanonickelate, this is the original structure, and after 90-degree angle, first, second, and third rotation are equivalent orientation with original structure, and last fourth structure is the identical structure if we compare it with first structures. That's why we can say it has C4 symmetry axis. Tetracyanonickelate as well as tetrachloroplatinate both has C4 axis of symmetry. Similarly, in case of cyclopentadienyl ion or cyclopentadiene molecule, C5 axis is passed through center of the center of the molecule like this. Just see this original structure: first, second, third, fourth, and fifth structure. So after 72-degree angle of rotation, the first, second, third, and fourth structure are equivalent to original structure, and the fifth structure, the last structure, fifth structure is identical to original structure. So that's why we can say it has C5 axis, and after fifth rotation, C5 5, after fifth rotation it gives identical structure. So it has C5 axis of symmetry. Similarly, if we see the benzene molecule, the one axis is passed. If we pass an axis, imaginary axis through center of this molecule, then after 60-degree rotation, it gives equivalent orientation. So this is equivalent orientation: first, second, third, and fourth and fifth. Fifth, first, second, third, and fourth and fifth are equivalent structure if we compare them with original structure. And if we see sixth structure, it is exactly the same structure with original structure. Why I am saying it is the exactly same? Because first carbon number, the number are given to the carbon, and the first carbon is occupy the same place. So that's why I'm saying that first structure is exactly same to sixth structure, and these are identical structure. So we can say these are identical structure. So benzene has a C6 symmetry axis, while cyclopentadienyl has C5 axis of symmetry. Now we have to point out one thing, that in a molecule there may be more than one symmetry axis or axis of symmetry, where axis having maximum of highest value of n, that is also known as higher symmetry, is known as principal axis, and the axis which has lower value of n, that will be known as subsidiary axis. Okay, and the relation between subsidiary axis and the principal axis is, principal axis will always be perpendicular to subsidiary axis, or subsidiary axis will always be perpendicular to principal axis. That thing we have to remember, that in a molecule there is a possibility that there may be more than one axis of symmetry, but which has the higher value of n, that will be principal axis, and the lower value of n will be subsidiary axis. The relation between subsidiary axis and principal axis is, principal axis will always be perpendicular to subsidiary axis, means both will have 90-degree angle between these two. So this thing we have to remember. For example, if we take an example of BF3, so if we can say that C3 axis is being passed through boron atom only, while if we pass an axis through boron and F, and if we give rotation with 180-degree angle, it will also give us equivalent orientation. Okay, so C2 axis is also present. So if we, it is from boron and 1F. So similarly, another axis will also be present through boron and second F. Similarly, from boron and third F. So there is C3 number of C2 will be present. And if we see the relation between this C2 and this C3, so C3 is, suppose this is a Z, this is the X, and this is the Y. So C3 axis is coming or passing through Z atom, Z axis, sorry, Z coordinates, while C2 axis is being passed through X coordinate or Y coordinate. So if we see these two axes, so we will find that both axes will be perpendicular to each other. So it is fitted in the relationship of principal axis and subsidiary axis. So we can say C3 is the principal axis because its n value is higher and high, and C2 will be the subsidiary axis because its n value 2 is lower than this C3. So that's why this is subsidiary axis and this is principal axis. Similarly, if we see tetracyanonickelate and or tetrachloroplatinate ion, so in this case, a C4 axis is passed through nickel atom only. This is the C4 and through Z coordinates. Okay, and another C2 axis is passed through this nickel atom and cyano ligand. Similarly, C2 axis is passed through this way, and this way, and this way. Okay, so we can say here 4 number of C2 present and 1 number of C4 present, but principal axis will be C4 because it has higher value of M, while C2 will be subsidiary axis because its N value is lower. Okay, so one thing we have to again remember that principal axis will always be one only. Principal axis हमेशा एक ही होगी, it will always be one, but subsidiary axis may be more than one. More than one. Okay, so that thing we have to remember. Similarly, if we see benzene molecule, it has an C6 symmetry axis which is passed through center of the molecule, but it also has 6 number of C2. These are passed through one carbon and another carbon like this. Okay, this you can see these C2 axis with this diagram. Okay, so it has 6 number of C2 and 1 number of C6 axis. Principal axis will be C6 and C2 will be subsidiary axis.